And so a few housekeeping things before we really get started. We are going to be recording, and the recording of the session will be available on the SEAS website and the same places where you found the link to get here this morning. So you'll be able to go back and watch again or share with your friends. The chat is turned off today in Zoom, but we will be using the Q&A. So if you have questions, you can go ahead and put them into the Q&A function. If you see questions that other people have put in that you think are really interesting or important, you can upvote those. And I have a couple of colleagues behind the scenes who will be answering some of those during the presentations. And then we'll have some time at the end to try to get to as many of them as we can. Also, we will have closed captioning for this session. And so if you need that, you can enable that at the bottom of your screen. With that, we'll go ahead and get started. So my name is Daniel Weinstock. I'm the Associate Director of Graduate Studies in Applied Computation. And I'm going to be joined by my colleague, Sheila Coveney, and between us, we're going to talk about 3 of the master's programs here at SEAS, the Computational Science Engineering, Data Science, and MS MBA programs. I'm going to cover Computational Science and Data Science, and then Sheila is going to come on and talk about the MS MBA. So let me go ahead and share my screen, and we'll get started. Okay. So before we get into details, a little bit about some acronyms that you might run across as you're listening to these presentations and as you're preparing your application. So everybody on the panel here today, this morning, works at SEAS, the School of Engineering and Applied Sciences. But all the graduate students in our master's programs and our PhD programs are all students within the Graduate School of Arts and Sciences, which is GSAS, and you'll be using that to submit your application to our programs. So that's the GSAS application. I work at IACS, the Institute for Applied Computational Science, and that's the organization within the School of Engineering that runs the master's programs in computational science engineering and in data science. And then finally, HBS, the Harvard Business School, is the other school that we jointly partner with to offer the MS MBA program that Sheila is going to talk about a little later. All right, so on to CSE and data science. So CSE, Computational Science and Engineering, really, both of these programs are interdisciplinary in their construction. So we think of CSE as existing to train students in methods and techniques from coming from computer science and from applied math, and then to use those methods to address problems in some domain of interest. And so some of the things that you might learn about within the program, numerical methods are listed at the bottom here: numerical methods, high performance computing, computational physics, the opportunity to simulate complex systems. Data science, similarly, is also an interdisciplinary program where here we're training students in methods coming from at the intersection of computer science and statistics, and the domain of interest is now wherever the data that you're working with is coming from. So things that people learn about in this program include statistical modeling, machine learning, and all varieties of ways of dealing with data, data management, data analysis, data visualization, and affiliated things. A little bit about our program philosophy. So how we have constructed and run these master's programs. They are embedded within Harvard. And what I mean by that is that though there are core courses that everybody within the master's programs takes that I'll talk about in a few minutes, when you're taking those courses, they aren't offered specifically and only for the master's students. And so you'll be sitting in class alongside students from other master's programs at Harvard, people in PhD programs from a variety of different departments, and even advanced undergraduates studying a variety of different things. And the elective courses that you take as part of the program are often courses that are already being offered by faculty within computer science, statistics, applied math, and more broadly across other departments and other schools here on campus. We have a flexible curriculum, though there is that core that I talked about. There also is a lot of flexibility built into the degree requirements, and this is done in recognition of the fact that these are interdisciplinary programs, and we do have students that are coming with different academic backgrounds, different work and life experiences, and with different interests. And so there's room within the curriculum to kind of make it what you want it to be and address your interests and needs. And we have project-based courses. So in many of the courses that you'll take towards earning the degree, instead of having a final exam at the end of the semester to demonstrate what you've learned, you demonstrate your mastery over what you've been taught during the semester by completing a project and actually implementing something using some of the methods that you've learned about. And many of the courses do this, and the types of students that we've had in the program tend to be attracted to those sorts of opportunities. A little bit about the students that we have had in the programs. So the IACS master's students across both of the CSE and Data Science master's programs. This is a look at their undergraduate majors. As you might imagine, a lot of people have backgrounds in math and statistics and computer science, but there's also people coming from a range of other fields, engineering, economics, and the physical and social sciences. The main point being that no matter what your background is, assuming that you have an interest and have an appropriate level of background in math and computer science and statistics, there definitely could be a place for you within our program. Students, in terms of their previous experience, we have many students in the program coming straight out of their undergraduate degrees, but we also have many students that have been out for a few years or more than a few years. Of those who are not coming straight from college, they typically have spent that time working in finance or technology, in consulting, or in research or academic positions. And many of them have also had previous advanced degrees, master's degrees, and even more advanced PhDs and law or medical degrees. So a wide range of backgrounds. Where do the students go afterwards? So this is a snapshot of where people have gone for the years 2019 to 2021. They're going into jobs in technology companies, both large and small and medium-sized. They're going and working in finance. They're working in a range of other industries, healthcare, consulting, other things. A small percentage, 10 to 15% maybe, go on to other graduate programs, typically PhD programs in applied math or computer science, or in the field of study that they had undertaken as undergraduates. In terms of the jobs that they're taking within these sectors, they're often taking jobs as software engineers, as data scientists, as data or machine learning engineers, as quantitative analysts within finance, and a variety of other types of positions. Turning now to the course requirements. For the CSE degree, we require 8 courses, and those are split between a set of required courses and a set of electives. So everyone is required to take Applied Math 205, which is a numerical methods course, There is a technical core of 3 other courses that you're required to take at least 2 of. Those include an applied math course in stochastic optimization and 2 computer science courses, one that's an introduction to software engineering for computational and data scientists, and one that is a course in high performance computing, parallel processing, parallel programming. Everyone's required to have a research experience, either by taking our capstone course or undertaking a thesis. I'll talk about both of those options in a minute. And then a set of electives, at least one of which needs to be in applied math, and at least one of which needs to be in computer science, a reflection of the sort of nature of the field where we're bringing together methods from these 2 different areas. And then 2 other electives, which could be more applied math and CS electives, or could be a chance to investigate options across other departments with the need for those electives to still have some computational component. So that could be a course in computational biology or econometrics or something along those lines. For data science, it's similarly broken down between a set of required and a set of elective courses. Here, for the data science degree, it requires 12 courses, 6 of which are requirements. So there's, again, a technical core. Here, there are 4 courses. Students are required to take each of those. There's a 2-semester sequence in data science. And then again, 2 of the courses that were part of the core for CSE, including the software engineering course and the stochastic optimization course. There's also a required course called critical thinking in data science, which asks students to think about the implications of the data science work that they're doing. So not just thinking about what's the fastest, coolest, newest algorithm I could use, but like what are the implications of using that in the world? How data science butts up against privacy and the law and bias and all of these sorts of ideas. Again, there's a requirement for a research experience, and then a set of 6 electives, at least one of which needs to be in computer science and one in statistics. For the research experiences, there are 2 ways of satisfying that requirement. One is with our capstone project course. In this course, students work in teams on projects sourced from industry partners and other outside government agencies or nonprofits, sometimes labs here at Harvard, with the goal of sort of simulating within the classroom kind of a work experience where you're given by the partner a data set and a problem statement, and you have to work with your team to figure out what it is you can accomplish over the course of the semester, and then so working through a set of milestones towards presenting something back to the partner at the end of the semester. The other option is to do a master's thesis, where you're taking on a computational or data science focused project advised by a faculty member or by one of our lecturers here at IACS. So this is a more academic style research experience, working one-on-one with a mentor, with the goal of completing your master's thesis and then defending that in front of a faculty committee at the end of the year. There is also the option of taking as one of your electives an independent study course. So this is an opportunity to do sort of a semester-long academic research project, sort of a shorter version of what the master's thesis is, and that can be used as one of your electives, but does not satisfy the requirement for the research experience. Here's a look at some of the partners that we've worked with over the last few years for the capstone course. The Boston Globe, some things locally, the Boston Globe, the MBTA, which is the local subway system, and then also, big national and international companies, Spotify, TripAdvisor, BASF, and we try to have a variety of projects each semester in terms of both who the partners are and what the focuses of those projects are. So it could be working on something that's more of a software engineering challenge for one project. Another one might be more of an image analysis project. Something else might be focused on natural language processing. So there's a real range of the types of experiences that you might get to have. If you do want to do a thesis, the things work slightly differently between the two programs. Within CSE, if you think that as you're starting to apply, you think you want to do a thesis, then you should go ahead and apply directly into a separate degree, which is the Master's of Engineering degree. It's a 2-year degree, which has all of the same requirements of the Master's of Science degree, which I've already discussed. Plus, you spend an additional year doing thesis leading up to a master's degree program. And then in data science, there's only one degree, so you just would apply it to the SM program in the same way, whether you wanted to do a thesis or not. For students who do decide that they want to choose the thesis option, we do allow them to opt out of up to 3 of the course requirements out of the 12. So that gives you time to do the actual thesis work. And again, you're doing the thesis research leading up to the defense of your thesis. And within either program, you're required to, during your first year, find a thesis advisor, come up with a project, and submit a proposal in the middle of the spring semester as to what it is you're going to be working on. And we have people who will work with you to try to help you find an advisor for if that's something that you're interested in. Finally, a little bit about applying to the degrees. So as I mentioned at the top, we use the GSAS application. You can find it online at the link that I've put up here. It's a little tricky to find our programs. So if you go within the application and you start filling it out, you want to go to the program selection page, find for the program Engineering and Applied Sciences, and then choose an option within that. So if you wanted to apply for CSE, you're going to choose as a subject the SM, ME, or ABSM in Computational Science Engineering. And then for your degree, you should choose either SM or ME. The ABSM is an option only for current Harvard undergraduate students who have an opportunity to do a joint undergraduate and graduate degree during their time on campus. So if you're applying from outside of Harvard College, you should only choose the SM or ME degree. For data science, it's a little easier. For subject, you're just going to choose SM in data science, and then the only degree option is SM. The application system is up and running and live now as we're meeting. So you can go ahead and get started as soon as you're ready. The deadline for submitting applications to our degrees is December 1st. We do not take GRE scores, so please don't send them to us. And you are required to submit either TOEFL or IELTS scores unless the primary language of instruction at your undergraduate institution was English. And then a little bit about applying, a little bit more about applying. So people often ask about the personal statement. This is obviously an important part of the application. So a few thoughts. This is your chance to introduce yourself to the admissions committee, right? So to tell them a little bit more about yourself than they can glean just from your sort of biographical information and your transcripts. So it's your chance to describe yourself, your experiences, what about your background and your training makes you an excellent candidate for this degree. It's a chance to explain why you've chosen to apply to this program and what you want to do in the future. What is it that studying in our program will allow you to go do in the future that you wouldn't be able to do otherwise? You are required to submit 3 letters of recommendation. People often ask who those should be from. They should be from the people who can make the best case as to why you're an excellent candidate to be admitted. They don't necessarily all have to be academic letters. If there's a manager at work, if you've been out of school for a while and the professors sort of remember that you were in class with them, but that's all they can say, you're probably better off getting other letters that can really address your strengths and weaknesses. And then finally, a little bit about the admissions criteria. So there are no formal prerequisites, as I showed you in terms of the academic background. You don't have to have a particular undergraduate degree to apply to these programs, but you do need to have a sufficient background in computer science and mathematics just in order to be able to engage with the course material and to really be successful in the program. And so as a baseline, sort of a minimum, you need to have a background in programming, and be fluent in at least one programming language. Courses at this point actually primarily tend to use Python, although there is some R and some MATLAB floating around there also. And then in terms of math, like we would expect people to have a background in linear algebra and differential equations, especially for CSE students, and statistical inference and probability. We try to take a very holistic approach to admissions. So we look at everything that you submit in the application materials, your previous degrees, where you went to school and what you studied, what your GPA was, your personal statement, your recommendation letters, your work or research experience. We try to look at everything. And what we're looking for is students who in one way or another have demonstrated a capacity to do the advanced computational work that underpins all of these degrees, and shows and can express an interest in applied computation and why and what it is they want to do with that. So with that, I'm going to turn things over to Sheila to talk about MSMBA. And like I said, there should be time at the end for both of us to answer questions. So Sheila.
Great. Thanks, Daniel. Hi, everyone. I'm Sheila Coveney from the Office of Academic Programs at CSE. It's great to have you all here. I'm going to talk a little bit about the MS MBA program. I'll go ahead and share my screen and just check with Daniel that he can see it. I had a little bit of problems earlier with a lag. Hopefully you all can see that now.
Yep.
Great, thank you. So the MS MBA is a program where applicants earn, or students actually earn 2 degrees in 2 years. So it's a Master of Science and Engineering Sciences, as well as an MBA. And it's a joint degree program between the School of Engineering and Applied Sciences and Harvard Business School. So a little bit different from the programs you just heard about. So if you are someone that is really excited and inspired by the idea of founding your own tech venture, or maybe leading a new tech venture within an established technology company, then this is definitely a program you'll be interested in, and that would be for you. So a few things, just a few statistics right off the bat. It is 21 months, so it's just under 2-year program. It is intense and rigorous. We fit a lot into those 21 months so that you can walk away with 2 degrees. We have students come early in the first year, so they take an intensive course in August called Design Theory and Practice. We have students take 4 full semesters of coursework, and then 2 intensive courses in the January term of both their first and second years. So that's how we fit everything in. We keep the cohort small, and that's purposeful. So we have about 30 students in each of the 2 years of the program, so about 60 students total. And we do that because we really want students to be able to bond with each other. Students have told us they feel like it's their MSMBA family, which we love. That's not to say that you don't have access to other broader communities, like your section at Harvard Business School, which is about 100 people, or the community of graduate students at CSE, which is comprised of CSE and Data Science master's students or PhD students. So you have broader communities, but you also have your MSMBA family, which you can come back to. We do require at least 2 years of work experience. So this is different than the programs you just heard about from Daniel. So upon matriculation, you have to have had at least 2 years of work experience. In an ideal world, you would have been designing or developing technology-intensive products. And then we do require that students have an undergraduate degree in engineering or computer science or a related field. So that could be something like, applied computation or, computational science and engineering, anything like that, applied math. So something I really want to hone in on here is design. And the reason why I want to do that is it really is central throughout the program. So this program is really a balance of design, innovation management, and engineering. Those kind of are the three areas you'll see woven throughout the program intentionally. And the reason that design is very intentional is that we see starting a new tech venture as really a series of design challenges that you'll be faced with. So once you graduate from the program and, hopefully you're founding your own startup, you could need to design a whole new organization or a new team or a new business model or a new product. And we want you to have that creative confidence and really be able to go through that design process, by the time you graduate and feel good about your skills in that area. So we take you through the design process several times over and make sure that that is key in all of the courses that we offer. So a few distinct areas about the program that I love, real world project courses. So a lot of our courses are based on really making sure you, like I said, you're going through that design process so that you're feeling confident by the end. Refining your creative technology and business decision-making skills, again, keeping that balance of sort of management, engineering, and design throughout. We do have, you will take electives, and you'll see more about this later in the presentation, but you will take electives at Cs, at HBS, but you will also take a core set of classes, we call them the joint degree classes, that have been created specifically for students in this program. And you take them just with your MSMBA cohort. Courses like design theory and practice, which I mentioned, technology venture immersion, designing technology ventures, courses like that again are just within your MSMBA group. All students are co-advised by both a C's, tenured C's faculty member and an HBS faculty member. So we think this is really important for you to have that advising on both, from both the business and engineering sides. We also have the joint degree courses, which are co-taught by both a C's and HBS faculty member. So we think that's important to keep the perspectives within those joint degree classes, as well as in the advising that you'll get outside of the classroom. We also have a great mentorship program that is set up. We have about 35 to 40, we call them program advisors. And these are folks that are accomplished in their own right. They are out in the world as VCs, as entrepreneurs, as founders, as, you name it. And many of whom are alums of either C's or HBS, but not all. But what they do have in common is they have all said, we think this program is really important. We like what you're doing. We want to sign up to help students, mentor them. They have served as sounding boards for students to, listen to their pitch deck or their pitch presentation. They've helped students network to find their summer internship or their full-time job. So they are a really key critical part of this program that is, I think, just one of the best benefits. And then finally, we do have financial aid for qualified applicants through Harvard Business School. So that is also a plus. Hopefully you can see this next screen. So shifting gears a little bit, I wanted to tell you just a little bit about the profile of the students that are in the cohorts of the about 60 that we have between the 2 years. Undergraduate degrees, I mentioned, it is a requirement to have either a CS or engineering degree or a related, a degree in a related field. About a third right now have a degree in computer science. The majority of the rest have a degree in engineering. That really spans from everything from, industrial, biochemical, mechie, you name it. And then we do have a few in the natural sciences and applied math. So where did students work before the MSMBA? Again, I think the takeaway here is they're coming from really all backgrounds. So there's really no one background that we're looking for. Students come from a diverse background. We've got folks that are, came from the military or aerospace, healthcare. A good portion have come from, working at large tech firms or the tech giants like Apple or Microsoft or Google, but certainly not everyone. And previously they held job titles like, some have come into the program having already founded their own startup, but that is by no means a requirement. So that should not turn anyone away. A few have. Many have been product managers or tech leads. So they have managed other engineers or been, a bench engineer in sort of a variety of disciplines. And then where do they go afterwards? This is pretty straightforward. By and large, a good portion do go on to found their own startup. A good portion also go on to be a product manager. The skills that they learn in this program are very transferable to that role. And then we have a smattering of students that will go on to do, operations, business operations roles. We've had some go into sales operations, or very tech heavy consulting or finance. And then finally, some that just have gone into the more business development aspect. So shifting gears again, now I want to get into a little bit more of the nuts and bolts about the curriculum and sort of what that looks like, because like I mentioned, we do fit a lot in, and we want to make sure that everything is covered within the 2 years. So in August of year one, you come early, just pretty much about August 1, and you'll take an intensive course called Design Theory and Practice. And that is where students work, again, just within their MS MBA cohort for about a good 3 weeks solid, day in, and night, and basically work with a client. This past year, students worked with Ferrari out of Italy, and trying to, basically the goal is to get through that design process and create some sort of new, whether it's a new technology or a new, anything that the company kind of needs. So last year, students worked with Philips Healthcare. This year, students worked with Ferrari. Well, we're not sure who the client will be next year, but anyways, you're working with a direct client, which we think is really important. And then in the first year, you're running through more of your required curriculum. So the courses in blue are the required curriculum at Harvard Business School. So a lot of the business classes that you'll get that foundation in. However, interspersed throughout are the classes in green. So you'll see more of those joint degree classes, the Engineering Design and Innovation Management Seminar, and then Technology Venture Immersion in January, which is amazing, goes through a lot of the actual prototyping of things, different products, as well as the customer review and customer discovery and interview phase, all the way through creating a pitch deck and presenting to program advisors. So that's kind of a very quick glimpse at year one. Year two, things get mixed up quite a bit in a good way, and you are able to take several electives. So 3 electives from the engineering side, 4 electives at Harvard Business School, and then again, more of the joint degree classes. So designing technology ventures. And then Launch Lab 1 in January and Launch Lab 2 in the spring is really a culmination of all the skills you have honed throughout the whole program. And that's when you really get to, students sometimes work on their own startup during those classes. If not, they have projects that faculty will provide for them, but that's where they kind of put everything together and really, come up with a new product or a new organization or something that is sort of founded from their themselves. So speaking of electives, I mentioned for the Master of Science on the engineering side, you'll need to take 3 electives. This is by no means an exhaustive list, so please do not take that as these are, this is the full list of courses you have to choose from, but these are some of the popular ones that students have enjoyed taking. And then I won't read these out, but I'll let you take a glimpse. And then on the business side, these are some of the classes that have been, popular for students at HBS to take as their electives. So you can see and again, this is by no means exhaustive, but just gives you hopefully an idea of what students have been interested in. Okay, finally, I'm going to wrap up with going through the application process because it is quite different than the process for CSE and data science. So just to put out there to begin with, candidates have to apply to and be accepted by both HBS and Cs in order to enroll in this MSMBA dual degree program. So starting on kind of the left-hand side, the left box, you would start by applying to Harvard Business School and checking a box that says you're interested in the MSMBA program. If you kind of get through their sort of first initial hurdle and are invited to interview at HBS, at that point, they will ask you to submit a 3rd letter of recommendation, which is a technical letter of recommendation. That's something that we would really want someone who could speak to your technical and quantitative skills. And then after the after the interview, your application would be passed along to the MS MBA committee, who will really review your application with an eye towards your preparation for the MS. And then finally, you'll be notified by both schools, by both HBS and Cs on the same day. At the bottom is a list of what's required for the application. I'm not going to read it out to you, but the one thing I do want to call out is that we do, for this program, require standardized test scores. So that is different from CSE and data science. The committees are agnostic to whether it is the GRE or the GMAT. It's up to you, whatever you think you'll do better in. So that's no, there's no difference, whichever you think you will excel at in a better way. So that's the application process. The dates are also, we have timelines and due dates that are a little bit different from CSE and data science. We have 2 rounds. We have passed the application deadline for round 1, but we are coming upon the application deadline for round 2, which is January 4th, 2023. And applicants, applying in that round will be notified by March 29th, 2023. And I should mention, students often ask, what is the difference between the rounds? Are spots saved in either round? Is there a benefit to applying to one versus the other? Absolutely no benefit to either. It's just, we want to give you a chance to apply when you feel ready. So we spread out the process throughout the year. There are plenty of spots in both rounds, so that's never a problem. So I'm going to wrap there. This is definitely a place you can get more information on our website, which is listed here, as well as you can also email admissions@hbs.edu. And we that is very much on top of responding to messages from that inbox. So please do reach out, and we hope to see your application come through. So I am going to stop sharing and invite Daniel back up. And then I think we're going to try to get to some of the questions in the chat. There have been, or in the Q&A, there have been quite a bit. Thank you so much for keeping them coming. Daniel, there was one that I wanted to get to first. There's a lot for CSE and data science. And I think, I'm not sure if you answered it already, but somebody did ask if students can, or applicants can shift from CSE, or swap basically between CSE and data science while they're in the program.
So yeah, no, we do not allow students to do that. So you should apply directly to the program CSE or data science that you are most interested in completing. So yeah, let's see some other ones that I picked out. So there was some questions about acceptance rates. They vary a little every year, but are typically in the 5 to 8% range. There was a question about research opportunities in various research groups at SEAS, like the visual computing group. Absolutely. I mean, there's no guaranteed spots in any of these groups for our master's students, but there definitely are opportunities to find research positions and opportunities within the visual computing group and many other groups at SEAS and other places on campus. Some students had asked about doing summer internships. That's definitely an option, and that could be via using CPT if you're an international student. So many of our students do take advantage of that. Let's see.
Maybe
someone asked, sorry, go ahead.
No, I was gonna say something about preparation. I'm seeing a few, somebody asked if differential equations and statistical inference are not on my transcript, but I have taken other math classes such as multivariable calculus and probability and statistics. Would that satisfy the base requirements of data science? Yeah, potentially. I mean, I think that, if we're interested in what not necessarily that you've taken any particular course. It's just that a transcript is the easiest way of transmitting the information that you have learned certain things. So our faculty who are reviewing the applications understand that when somebody has on their transcript an undergraduate course in a particular subject, we understand what that means. If you've learned some of these things in other places, that's totally legitimate, whether that's because it's something that you needed while you were working, or it's something that came up because you were doing a research project, or just through your own self-study. Those are all totally legitimate ways of learning things. You just need to find places in the application to give that information to the application or the admissions committee readers so that they know what it is that and can do.
And so whether that's in your statement of purpose, personal statement, or whether it's like putting in a separate like additional document, sort of going over like additional like background skills that you have, or whether it's having some of your letter writers attest to your skills in certain areas, like you just need to find ways in the application to make it clear to the committee what it is that you are bringing to the table. So there was a question about whether like students in CSE can take data science core courses and vice versa. Absolutely, those are legitimate choices as electives. So if you're a CSE student and you want to take the intro to and advanced data science courses, absolutely, you're welcome to do that, and vice versa.
A bunch of questions about electives. So is it possible to take electives from different departments such as economics or finance?
Absolutely, there's the opportunity to do that. There does need to be, there are some details around how much computational content is in some of the sort of outside electives, but there's definitely room to explore those things, and we can work with students to help them figure out what can count and what can't. So, oh, this is a good question. So somebody asked, given sort of the multidisciplinary nature of the data science program, do we provide any sort of background or catch-up material over the summer? We do actually do that. So everybody who is admitted and decides to enroll, we will send people out sometime in June, probably, of next year. We've put together some online sort of introductory material, and so you're welcome to take advantage of as much or as little as that as you feel like you need. But yeah, we do try to provide some background material so that everybody's up to speed and can hit the ground running when they get here in September.
That's great. Just looking, let's see. Here's an interesting question. Sort of a question about wanting to be a data science technical founder. How do you kind of navigate between choosing a master's of pure data science and the MS MBA?
Yeah, I mean, that's
good question.
That's a good question. That's an interesting choice. I think it depends on the person and exactly what they want to focus on. Obviously, the data science program is going to provide a much deeper technical background than there's room to get within the MSMBA, just because of the nature of the requirements. And but the MSMBA is going to give you a lot more help and training around thinking about like a product and founding a company and all of the sort of skills and things that you need to think about to do that. So it sort of just depends on what your own interests and emphasis you want to have is. There is, you know, if you're in MSMBA, you won't get as deep a dive into the technical things, but there is room to do some of the technical preparation within that. And similarly, if you're a data science student, while you're not getting an MBA, so like that's a clear difference, but there are resources and opportunities on campus, like there's the Harvard iLab and other things. So there are opportunities to engage with people who share your entrepreneurial interests and to get some help and advice along those lines. So it's sort of, there's no clear-cut answer to that, I guess, but either one could be a legitimate choice.
Yeah, I think that's a great answer. And this is a good question too. Speaking of differences in the programs, what would you say high level is the difference between CSE and data science, if choosing between those two?
I'd say that there's sort of a couple of ways that you could think about that. So one is at a very high level, sort of thinking about well, some people are very interested in having a degree with a certain name, and so you could choose on those on that level. There is a difference in emphasis in terms of which I tried to get out at in the presentation around data science is obviously incorporates more statistics, has an emphasis on data handling and data analysis and data visualization, et cetera. CSE, a little bit more around numerical methods and high performance computing and computational physical and social sciences. Obviously, there's a lot of overlap in the way these two things are defined. So at a more granular level, you might choose just based on there's a certain set of requirements, and these ones appeal to me more than those ones. Or, CSE, it's possible to complete the Masters of Science in a single academic year. So some students choose on that basis, whether because for financial reasons or just for time in their life, they only have time to be here for a year. So there's a variety of reasons why you might choose one or the other.
Okay, thank you.
Someone asked about master's theses. I don't have prepped here a list of previous thesis projects that I can share, but I can say that we've had students that have worked on with a variety, large variety of faculty, both at CSE and many of our different areas in computer science and applied math and different areas within engineering. But we've also had students work with faculty in statistics, and with faculty from a wide range of other parts of Harvard. So the School of Public Health, the medical school. So there is a wide range of possible thesis advisors and topics that can be considered.
Great. Just looking for some other broader themes here. Maybe you could comment, Daniel, on research. So is it possible to engage in research that is still data science heavy, that is outside of the department? So for example, biology or earth science?
Absolutely. Yeah, that's what I was just trying to get out a minute ago. Like there's definitely, whether that's for a thesis or just for an independent study project, there's definitely, you're welcome to seek research opportunities across the university. With obviously we want it to have the research to be a chance for you to apply what you're learning in the program, and so there should be a computational or data science focus to the work that you're doing. But yes, absolutely, if you wanted to do that within the context of a biology lab or with an economics professor, there's definitely the opportunity to do that.
Okay. And then I'm seeing a few questions about the application, specifically including, maybe links to some of the projects that they've done or their CV or so.
There's definitely there's definitely an option to upload a CV, and that can be very helpful, just to give like a quick snapshot of your background. And there also is an option to include information about previous projects, previous research experience, and yeah, I mean all that is helpful information and will be taken into account when your application is being evaluated.
Great. And I guess in that same line of thinking, someone asked about submitting 4 letters of recommendation. Do the first 3 weigh more, or are they equally treated? What's your advice on that?
My general advice is probably 3 is in almost all cases enough. And it's I think, an unusual case where the fourth letter is really providing new information that the first three weren't able to get at. So I would say in most cases, just submit three.
Sounds good. Anything else you're seeing, Daniel, that's?
I think we've covered most of it. Oh, there's one about grades. If you're a current undergraduate student in your senior year, there is an opportunity to submit fall semester grades, even if those come in after the application deadline. That's something that you can, there's a form within the application system that you can submit those later on, and they'll be added to your application file. And so that's, you want to make sure that the committee is seeing that information and taking that into account. That's definitely something that can be added after the deadline. That's one of the few things that gets added into the to the file after the deadline.
And a question or two about previous degrees. Maybe, they have related degrees, but not specifically engineering. What's your take on that?
In terms of bachelor's degrees, there's no requirement to have a specific degree in engineering or computer science or whatever else. Like I tried to say earlier, we expect and require that students have an appropriate sort of technical background to be able to successfully take the courses and engage with the faculty and the other students, but that doesn't have to have come from completing a particular undergraduate degree. If you had an undergraduate degree in some far off field that is completely unrelated, but you have other experience in doing, as out working or whatever, as a software engineer or something that's related, and you sort of picked up these skills after your undergraduate degree, that's totally fine. And again, you just need to make it clear what you've learned in those situations that qualifies you for the master's degree somewhere in your application, since that won't be obvious from your undergraduate transcript.
Got it. Sounds good. Let's see. Well, unless we have any other sort of broad themes that you can think of, Daniel, maybe we'll.
I think we can end it here. Well, yeah, thank you everyone for attending. And we hope that we will see your applications later this fall. As I mentioned at the top, this session was recorded. We will be placing links to the recording up on the CE's website in the same places where you found the link to this session, probably sometime next week. And so you're welcome to review this at that time. But for now, we'll sign off and just say thanks for joining us.
Great. Thanks, everyone. Have a good day.